Okay, this video is to go over the solving systems of inequalities. We want to see how we would even graph an inequality and just kind of review that. So we're going to just practice on here for a minute. If I were to graph the inequality x is greater than 2, okay? So I'm graphing x is greater than 2. That's a wonderful greater sign, but I need to go out and say, okay, x is 1, 2. If I say x is equal to 2, then it's everything on this line right here. Okay? So just like that. Now, I made it a dashed line because we're seeing that x is greater than 2, not equal to 2. It's just greater than 2. So if it's greater than 2, we do a dashed line. If it's greater than or equal to 2, we do a solid line. But it's not just 2, it's everything greater than 2. All of that is included. Okay, so we're going to put that right there and say, okay, now with that, do we have it solved? Well, if it's only x is greater than 2, yes. The next part of that says, of number 1, says 2x plus y is less than or equal to 4. Okay, now we need to get y all by itself, so it follows the y equals mx plus b layout that we're familiar with. So we're going to minus 2x, and we're left with y is less than or equal to. I don't need to change the direction of the sign because we're only subtracting. That's only when you multiply or divide by a negative. Y is less than or equal to negative 2x plus 4. And then I'm just going to draw a line and put a 1, so I have my rise over run. Okay, so now we have a formula we can graph. We say, okay, our y-intercept is plus 4. Well, if it's plus 4, we go up 1, 2, 3, 4. There's plus 4. And we have a rise of negative 2 and a run of 1. Rise over run. So we go down 2 and over 1. And then we are left with this. Now, are we doing a solid line or a dashed line? Well, it's less than or equal to, so it's just going to be a solid line. So now we have both of our lines, and we know that this one's greater than, and the new one we just did is less than or equal to. So it's everything less than that line. Okay? If we do that, you can see right down here where the two lines are coming together, where they're overlapping. Okay? That's the solution. So what we would do is we would shade in all of that. And that's the answer. Okay? I think I'm zoomed in a little too much. I keep knocking you off the screen there. Okay? So number 1, that's how you would solve it. If we look at number 2, I'll do this one right on here. They're both set up in the y equals mx plus b. This one is just telling us that y is everything less than or equal to negative 1. Okay? So if I draw a line, and I can do a solid line because it's less than or equal to. So if I do a solid line at negative 1 right here, I say, okay, it's got to be less than or equal to all of that. Okay? So I've just got to keep that in my mind, that that's where we've got to shade. Okay? The next one, where's the y-intercept? Y-intercept is at negative 6. And I know I need to do a rise over run. 3, 1, 2, 3 over 1. Okay? And with that, I have my second line, but that one's only greater than. So my second line needs to be a dashed line. Something like that. probably smaller dashes, but so now we have everything below it, that line, and greater than means everything above that line. So we look for where the two overlap. And we see right in this corner right here is where they overlap. Now if you don't have the fancy color films, here's what you do. You say, okay, everything down here and everything up here. So I've got arrows, and where the two arrows cross, that's where you shade in, down there. Okay, so let me do one more, and then I'll leave the rest to you. Both of these are not in the form of y equals mx plus b. And all that is y equals slope plus, or x, plus y-intercept. Okay? So we need it in that format. So in order to get that, I'm going to minus an x over here, and then I'm left with negative y is less than 7. We'll put the x first. Negative x plus 7. I'll do this on scratch paper. Let me rewrite that. Negative y is greater than negative x plus 7. So all I did was minus x from both sides. Okay, now I need to get rid of this, so I'm going to multiply the whole thing times a negative 1. Both sides. And that turns that to a positive y, but it changes the sign because it's a negative number we're multiplying across. That changes that to just a positive 1x, or positive x, minus 7. Don't forget to change the sign of everything. Now with that, we're saying, okay, here's our rise over run. Great, we have our first graph. We cross the y-intercept, it's negative 7. We have a rise over run of 1 and 1, 1 over 1, 1 over 1, and so on. And we can see that there's a line here. Now, is it a solid or a dashed line? Well, it's greater than, so that tells us that it is a dashed line. There's no equal to. Okay, so if we do that, we just do a dashed line. Okay, and now let's solve for the next one. Okay, if I do x plus y is greater or is less than 4, we want to subtract the x. Subtract the x. We're left with y is less than negative x plus 4. I like the x up front. So that's a negative 1x. We're going to turn it into a fraction. And we see, okay, it crosses the y-intercept at 4 right here. So I'm going to put a dot right there. And it goes down 1 to the right 1. Down 1 over 1. Down 1 over 1. And it also is just less than, but not equal to. So when I draw this line, I just want it to be a dashed line as well. Okay, so we have two dashed lines. The one we just drew is everything less than. So I'm going to draw the arrows to help me remember, okay, it's everything less than that or lower than that. Okay, now the one we did earlier, everything was greater than. Okay, so I'm going to draw these arrows up to show greater than. And I can see right where they overlap, where the two arrows overlap. So if we do greater than and less than, you can see where the two colors overlap. And that is the answer. Where the two colors cross, we can say, hey, everything inside of this shaded area here would solve that system of inequalities. Okay, so there's some ideas on how to do it. Hopefully that helps. Let me know if you have any more questions.